All right. First, thanks, Sans, for having me here. It's a pleasure to be here. And today we're going to talk about the approach and kind of research we are doing here, like to try to achieve least privilege at AWS. And so like we start with Cloudsplaining, and so we saw that Cloudsplaining itself, it's awesome too, but we need some extra sauce. And so we start to use it, putting the information at Elastic Stack. And so we need to add the access analyzer. And so that's the story I'm going to tell here. My name is Rodrigo Montoro. My nickname is Spooker. I'm SpookerLab at Twitter. I do research and threat detection at Tempest Security down here in Brazil. I live in Florianopolis. Florianopolis is the south of Brazil. It's an island. It's a pretty beautiful place. If you Google for that, you see like we have beaches all around the place. I have a 8-year-old son. And well, I'm not with my family. I'm trying to do like, and I'm not on the computer. I'm trying to do some sports. I paddling, I do CrossFit. I did the Ironman twice, and I probably will not do anymore because too much. And the motivation here, as I mentioned, like we have our cloud environment and you need to try to fix the problems. And when you are using the cloud, we have like a bunch of problems. Like first we have like multiple accounts. And so like a tool that just runs standalone is not going to fit very well. Second, we have the application and infrastructures and all that. A lot of same problems we could have on premise, depends how we're deploying. And so you have like the misconfiguration in the control plane. That's really, really important to take a look, like using the CSPM tools and all that stuff. And we have the IAM permissions problem. That's where sits a lot of problems, and they're mostly where our research is going to fit, especially because the motivation starts because like when you start to look using Cloudsplaining, you have like more than 500 policies to analyze. And like if you start to think like, okay, like how you do the prioritization of that. And so mostly we start the first version of this research, like using the Cloudsplaining. And so you saw that we need to add to somewhere else to put all together and try to figure out the prioritization. And when you fix that, like we did the risk score and figure out like, okay, now we have the prioritization, we start to have another problem. Like, because when you find a policy with too much permissions, that's okay, that's cool. But how I solve that? And we as security analysts, we don't have context. Like we don't know like with this, the data science profile, the dev profile, the infrastructure profile, they do a lot of different things. And so they need different actions, this kind of thing. And so where we add the access analyzer, like to help us based on data and the daily use to have something, a draft or some fix. And based on that, we create our agenda. And our agenda, basically, I do some introduction about the IAM, because I don't know like if everybody knows that, but it's a very quick overview. And now the keys are the new perimeter. And so showing that like we figure out like, oh, since that's the perimeter, now I need to take care with the privilege. And so least privilege is mandatory. And so we have the core of this idea. It's Cloudsplaining that was created by Kennard McQuaid. Thanks, Kennard McQuaid. Great too. And so we add on top of the Cloudsplaining, we add our extra sauce, that the risk score stuff. And so we have the access analyzer. And the access analyzer, I'm just showing you what it does and some conclusions. Like the idea like is to have something more automatic. And I'll show you guys. So a brief overview about the identity and access management. AWS, I'm considering like the basics, like I am user and the default keys. And so like when you create a user, it's everything denied by default. You need to attach a policy And those policies will have the permissions that control access to the service. And it has a JSON format. And mostly it have the part contents inside. What that means? Like you have the principles, depends on the policy type. You have the actions that you have access, like usually is the service and the action itself. Some service has hundreds of actions and some service has just a few. But in total, you have like more than 12,000 actions. That's a lot. And so if you go there and use the administrator access, you are giving access to all those actions. That will give you access to all the almost 300 servers or something close to that AWS has. And so you have the resource and you have the condition. And this part is very, very important. Like, because when we try about like mitigating and least privilege, like it's not all about removing the permissions. Like it's about like and mitigating the problems. And so resource and conditionals fits there, like because the actions are there and some analysts will need that actions. Like, okay, there is no problem on that. But based on that, you need to try to make the attacker life harder. And so research and conditions is really, really important. And so basically you have like a policy, you could have like multiple statements. There is a byte size there, I don't remember, but you probably have the effect, it's allow, the principle, the action, the resource, and the conditional block. And a very simple way, like we have the effect allow, and we have the action, the service, and the action related, and in a very specific resource. And here you don't have the conditional block, for example. Like this could be very complex. Like if you go to the AWS IAM manual, they have something like, I think, 2,000 pages or more. And how it works, like you have the authorization, you have the authentication before. And so it could be a user, a whole SSO with some IDP, some application, or you could have a cross accounts. And here, in my opinion, is where the most dangerous parts holds, because you don't have information about how secure this account is. But when you authenticate, it will have, like, as I mentioned, like by default, everything is denied, but you have probably a policy attached. It could be an identity policy, resource-based policy, a session policy, permission boundary, and so on. And those policies will dictate that which actions you could use, like, for example, run instance, that when you start an instance, and in which resource. And so based on that, like you could come from here or from here. You have access based on the permissions. And so that's why it's very, very important to have least privilege, because this is basically an access key, and this is basic access key in the other side of on the customer side. And the policy could fit like in different modes. Like you have the managed policy that's created by AWS, and like the advantage here, it has the same name and it's in all accounts that AWS have. And the disadvantage here, like you could not control the actions that are there. They could remove or add something to the policy. You could the resources start, and there is no conditional mostly. Like there is some condition in some policies, but most of the policy doesn't have condition. And so you have the customer managed policy, that I think the best way to control that. But you need to deploy the policy in all your accounts, and when you change something, you need to deploy the updates in all your accounts. But now with the automation, I think it's not a big deal. And you have the inline policy that is created inside the principal. And so, like, unless, at least in my opinion, if you don't have something very, very specific, I don't think it's the best way to use it. But you could hide, like, using this three kind of policy. You could have the permissions there. And all the actions are, they split in access level. And so the list, the read, the write, permissionment, and tagging. And like most of the time, the dangerous part sits here, like rights and permissions management. And that being said, like we have the keys are the new perimeter. And so like, just to give some introduction, what is a key? Like a key basically is a combination of an access key that is 20 chairs, something like this, with a secret that has 4 chairs. And depending on the keys, most of the times a regular user, if you IAM user, if you create a key, it will be the A key, IA key. And when you have a temporary key that usually lives like for 1 to 12 hours, it's the Asia key. So you start with Asia here, ASIA. And this is a key. And what you could do with this key? With this key, you have access to the control plane, and based on the permissions, you have access to anything. And how you get access to a key? So that's the very important part. Like you could have access, like creating on the portal time, like when you have access to the portal, like, and you could create a key to the user, and you need to access the key like that time, the secret, because like if you didn't save the secret, it's not going to show anymore. And this usually, like when you create a key, you usually have a CSV file. They suggest a CSV file to download. And so probably if you go to the download folder of a cloud user, you probably find some CSV because we usually forget to erase. And some application. So maybe they have some hard-coded key in the application and you could abuse by some flaw or something else. Using some server-side request forgery in access the metadata, like in Sumer, like usually the application and some instance, they have wholly associated, and this wholly contains a policy associated. And like when you discover some flaw like server-side request forgery, or you could upload a web shell or something like that, you could access the metadata and you have the path that's it's not hard to discover, and you have access to an Asia key, and so you could pivot to the control plane. And another and the most common way is code leak. Like it's pretty common. If you use something like SSH Git, in the monitor the Git, you see like a lot of like thousands of keys like per week easily, and so that's the most common way. And if you could have access to some server or some developer or some infrastructure guy, and you could find information on .aws/credentials. It's everything saved here, like in plain text. You could try to find the history. And so it's pretty common to export a variable. And so maybe it's there, or hard coding some automation, some code you use to do your job. And a third part, it's a pain, because like when you have a partner or some service that you are using, usually you create a cross account. And so like if I get access to the partner account, and I could assume that role, I could jump to your account like as a user with the permission. So that's why least privilege is very, very important. And tools configuration, maybe you have some tools that save the information in plain text. And social engineer, it's basic a user and pass. The biggest difference, it's now that like if you have a user, some automation or attacker, if they have access to a key, they will connect in the same place, and they don't need to discover anything, because when you have some problems with the on-premise information, some data leak with the on-premise, you need to discover, you need to break the perimeter, get inside, discover the server, and so try to access. With an access key, like you basically pip install AWS CLI, AWS configure, and boom, you configure, and it will automatically route you to the account. And based on your permissions, you could do a lot of things or not. Like if you try to achieve least privilege, and if you have like conditional And the idea is, okay, like we are safe. And think about that, like now, okay, like keys, the perimeter, like it's pretty easy to use because the AWS API is public. How I could mitigate my problems and try to achieve the least privilege. And so that's where fits the core of this research, Cloudsplaining. Cloudsplaining is a tool created by Kennard McQuaid. And the main idea is identify least privilege violations. And it's divided, split in 5 main finds. Privilege escalation actions that will permit the privilege escalation, some finds that will do the data filtration, some actions that will do some infrastructure modification. A lot of the actions could do that because most of the cloud is about infrastructure. And some will do some credential exposure, and others will do some research exposure. And the research exposure, for example, like the S3 put bucket policy, it could just, if the attacker has a key that has access to this, it could make the bucket public, and anyone could have access to the data, and to have sensitive data, you will be leaked, this kind of things. And this update assume role policy, you could create the cross account with your attacker account, and so you could access other things. Data filtration, for example, S3 get object, that you get access you to access some S3 information. So it's all depends, like if you have the resource star, like you could have access to any object inside any bucket. And so for that filtration, and so infrastructure modification. And so infrastructure modification could do something like start an instance, stop an instance, run a new instance, authorize security group. So you change the security group ingress. So you could change like the part, oh, this part's closed, but I will open, and so I could, I will have access. The credential exposure, that will return some secret, access screen secrets, and it's very important, and because you could have different access, and so maybe you could pivot. And sometimes like we need to figure out, like it's not all about become an administrator. Like maybe the goal is to have access to something important in your company, and maybe you don't need it. And so maybe this change, this lateral movement, like changing some permissions, maybe will work. Like, and so those actions will return a credential. And the privilege escalation mostly are based on RHINE security. So if you didn't read, it's mandatory read. It's really, really cool. Rhino has a lot of cool things there. And basically, like as it's saying here, it will allow you to go from a basic user to a privileged user. Mostly depends on IAM actions. And like by default, the default output, it's a HTML file, and that's pretty cool. Like work as a charm, like you have the Cloudsplaining, and so you have this executive summary that you have the risk, how many times policy were found, and the severity here. And so you have the customer policy, the inline policy, the AWS managed policy. So it's split on principles. And so you have some guidance and appends that I don't know what's going on. And so you just click there, and it's pretty straight to go, like, and it helps on the triage and on the fix, and it's a really great tool. Like, and so if you click in customer managed policy, you have the policy name, and so you see like, and how many principles is attached, the number of actions that's related to each of the finds, and so on. And if you start to click, you start to drill down, like, and you have the policy here, and you have the user, it's attached. You have the service here, like, and you have the finds. And so if you click like, oh, but what do you have for privilege escalation? And so you have all the permissions, all the actions that's related. And so if you click here, if you go to some explanation, like how to abuse and this kind of things, And a very important part, especially for security analysts, since most of the time we have a kind of payload. Like imagine, like if you have intrusion detection alert, like it's pretty good to have the payload, so you could compare with the detection and make sure that's not a false positive. And here you have the policy documented, that is the policy, and you could look on the policy, the whole policy, and figure out like, oh, okay, I need to maybe add something here. But what is the problem? Like running Cloudsplaining in third one account, like I have like third one's different files, and I need to put out together. And on those third one files, I have more than 500. Oh, sorry. So I need to do the prioritization. And so we start also, so we need to add some extra sauce on top of Cloudsplaining. Cloudsplaining doing most of the job. It's cool, but I need to try to make my life easier. And so I start to do some prioritization based on the type of finds. And so if you have and on your policy, you have something that's high, medium, and low, it will be top one, prioritization one, because you have all the possible finds. Like you have finds that's high, a find that's medium, a find that's low. If you have none, the prioritization will be 8. I start to do that. It's helped a bit, but now instead of having 500, I have like a bit more than 120 something with the priority one. That helps, but it's not that good. I need more granularity. And so we start to do some weights based on the actions count. And so like based on the number of actions for each find, we start to create some weights. And so based on that, we have 2 scores here. And we start to do the mitigation axis. And so I did add to the score yet, but the mitigation actions I used to do as a filter to ignore in the very first step, especially if they have conditional analysis, because like conditionals mitigate a lot the problem. And what did you do? We start to look on JSON output. And so here we start to use the Elasticsearch stuff. And we start to use the Logstash. And besides the HTML file, Cloudsplaining has a JSON output, and it has the group, the user, the managed policy, the customer managed policy, inline policy, all the information there. And we have the policy here itself, and here you have the finds, the actions related to it of the risk. Like, so you have one for that filtration, one for credential exposure, none for privilege escalation, and so on. And we start to add some filter at Logstash, and what you get? We start to get the length of that information in this variable, total infrastructure modification, for privilege escalation, credential exposure, research exposure, and so on. And after that, like if those variables are bigger than 0, and so we set a new variable, his high true, his median, because we have those 3 median. I keep the default Cloudsplaining values, and total infrastructure modification, risk low true. And so that's bring us the matrix. And so prior to 1, if you have like the high risk, medium, low, and the priority 8, like if you have none of them, it's all 0. That's bringing me to this score. Remember, this is a researching test number that was testing mostly in my environment. Like it probably could work fine in yours, but maybe not, because it's something very dynamic. And so we set this score prioritization value with those values. That's pretty trivial, this first. But here we have a kind of bigger problem, because we have something like privilege escalation. We have just 22 actions mapped, but the impact is high. And infrastructure modification, the impact is low, but we have thousands of actions. And so like if you use like numbers that close, maybe something with a lot of actions that's more common to have infrastructure modification, we will be like consider the risk score bigger than something maybe that just have some 5 privilege escalation, but privilege escalation is more critical. And so we set those weights. Remember that research and test number. And so we got those values. And what we did, we start to, first we create a new variable that we call action count score. And so we get the total number of the events and multiply versus the weight of that actions or that find. And so we did all that for, and in the end, we set a new variable that we call the risk score. That it's the sum of action score plus prioritization, that matrix stuff like for 1 to 8 that I showed before. And we have the mitigations that we didn't add yet. We start to do some numbers here, but we have distress mitigation, like if you have just research, if you have conditional, and you have research and conditional. But on this very first phase, you just use the Elasticsearch filters. And what you get here, like, as I mentioned, we have like more than 500 policies. And so the risk right, risk medium, risk low, as I told, like a lot of has this, that's a big problem, but we need to fix, right? And so like, that's where it's introduced the number of actions that you multiply plus the weight. It's on test yet. And so that we get, like, so we got more granularity here. And so now we have a prioritization, like this is more critical based on our risk score. The perfect part, like to do the very right prioritization, but I cannot do that in our company because I don't have context. It's like based on the accounts, the type of account, because some accounts have more sensitive data. It's on production, has more sensitive information and so on. And so this would, plus this would be the perfect to get access to that. And so when we start we arrive here and you have like the 500, like some have the same risk score, it's okay, because some are copies of each other. When you arrive here, they start to ask me like, okay, but how are you going to solve? And so like after we get the prioritization, we start to look at Access Analyzer. What is Access Analyzer? Just to summarize here, analyze your Cloudflare events to identify actions and service that has been used by IAM entities. And so what you could do, you have the name, but on those JSON files, you could get the attached yarn related to the user and whole. And so you could use the policy, Access Analyzer policy suggestion and generate a policy, review a policy, and create and attach the new policy. This is a process. This is going to solve the problem. No, it's probably going to mitigate, but it's not going to solve, because like you need to go this time by time. And basically, if you look on the interface, you have the actions related. The cool about that, you could look the real data, like from CloudTrail for the last 3 months. And if the user or the principal didn't use some actions like in 3 months, it's probably not going to use, not going to be missed. And so, and you could add some conditionals here. So this process here is a bit manual so far, but the idea is to get everything automated. And I think I don't know about the time, but some future in conclusion, automates the flow. Like, and when we mean automate the flow, something like we could run Cloudsplaining, do the risk analysis. And so if the threshold is bigger than next, we just go to because we could use the bottle tree and ask the Access Analyzer API and just go to Slack and say, oh, this policy is 2 permissions. Those users are related, and this is the draft of something to start. So like you have something, and change IAM is a pretty complex place. It's not something easy. We want to extend the analysis to group roles, inline policy, and users, those information. And so it could be more granular here. And some conclusion, like since the keys are the new perimeter, like least privilege is something mandatory. Like the previous talk, they are talking about something similar in Azure, like because it's very, very important to have some controls. Like if you have something that has permission management, you must have a conditional access. Like what I mean by conditional access, a source IP, like for a bastion host, you could assume this role and use those permissions if you are from here. Because like when the attacker has access to your key, like, and try to use it, it will generate a lot of deny. You could just create a trigger on that, and so you could just revoke that key, and you win the battle, right? It will have access, but it will need to discover the conditional, and so you will probably be faster. Train your team, automate the process, repeat all the steps, because we need to repeat all the process all the time, because like now I have 500, tomorrow maybe I have 1,000, and maybe and the cloud is so live that it's changed too much. And that's it. Thank you very much. I hope you guys like it, and those are my contents.